super nice to see everyone here. It's the first protocol research call, co-organized by myself and Ansgar and many of our friends at the Ethereum Foundation and beyond. We've been discussing like various shapes of this call for some time. Like we've always felt, yeah, there needs to be one of these channels where we can discuss some of the questions that we do discuss on Discord, on Telegram, in conferences, etc. Like have a bit more of a shelling point for this to happen. So we hope that it serves this purpose. So I want to start with like a couple of thoughts on what the call is, where we intend to go with this, and then we'll get down to the topics at hand. So some of the goals I would say are making this venue, which is kind of a good place to present ideas that are maybe not fully formed yet, or that seem important, but we're not like extremely convinced yet. Synthesizing the discourse when we post a lot of things, a lot of if research, a lot of tweets. So trying to paint like a more holistic picture. We want this call to have like a fairly strong focus on the why rather than the how. So questioning like why we do certain things, or why certain proposals are important, or why we think they make sense. And the last part that I think would be very nice for this call is to essentially accelerate integration of some ideas into the roadmap. So oftentimes it feels like we have many pieces and we spend a lot of time like really sharpening them. But it's really about like putting them together in a whole that makes sense. That's kind of a tricky part. And another question that research alone or dev alone can answer. So very important to have these conversations together. It's also a larger conversation. Like this call is only 90 minutes. I hope it doesn't feel too long by the end of it. But it's clearly not like we're not going to solve everything in 90 minutes monthly. But we hope that this call is more like a root of a larger asynchronous discussion that will happen like through posts, as they already do, papers and any other artifacts that are produced like throughout these conversations. But the calls can maybe be a bit of like a way to pose the right questions, or to frame them in a way that single posts don't address. And we hope that the calls can also be used as a reference, where we can say, oh, if you want the lowdown on this topic, check out that call and the associated references. I think that would be a very nice goal. I still think we can make progress. Like I don't think it's just synthesizing stuff. I think through the conversations that we have here, we can probably find some agreement on the places where we converge. Oftentimes, I find that there's more agreement than I expect on certain topics, especially spicy ones. Maybe we can also figure out where there are gaps. So when we present like a certain picture, somebody can come in and say, "Oh, you're completely forgetting about that part." That I think is very important. And sometimes we might also like figure out the path forward, or tell ourselves, okay, this is important to spend our attention thinking about this problem a bit more. And I think that can also come up here. I'll leave that part to Ansgar.
Yeah, I just wanted to briefly jump in, because when we talk about a kind of protocol research call, this is kind of intimately tied to the question of where should Ethereum go on the technical side. And I do think having some sort of systematization when talking about this is useful. This is here really just a proposal kind of by me to try to categorize a little bit where I see the current kind of research directions going. This is in itself in a way already opinionated. So if you feel like, hey, this is not how I think about the short term or the longer term priorities or something, no worries. This is really just an attempt at trying to categorize a little bit. But I think over the next few research calls, it's good to have this as a bit of a backdrop. So basically the way I see the research landscape right now on Ethereum is we have this natural split. You see the two rows: consensus layer, execution layer. Given that we have this duplication of clients and of client teams, usually these two sides have relatively independent features and feature focuses. Of course, there's often overlap. So it kind of makes sense to treat them, to look at them somewhat individually. And then I distinguished a little bit between like the shorter term priorities. So you can think like what are going to be the focus, the main focus areas for the next 3, 4 hard forks, that kind of timeline. And then medium term meaning for the time after. And so the way I see it right now is that on the consensus layer, really the main short-term priority that we have right now is the blob throughput scaling. And we laid the groundwork there with 4.4, and now with the upcoming PIADAS, we're really starting to rapidly ramp that up. So I hope that that's going to be exciting. That of course doesn't mean, again, short term. It's just like that's the main theme I see there. There are other exciting features like fossil, for example, censorship resistance, that might still very much be in these forks in the short term. But this is the main theme here that I see. And then in the medium term, of course, there's Justin's big effort around the beam chain. The way I would conceptualize that is really just that the beacon chain on Ethereum was basically like the very first kind of big like big attempt at getting kind of the proof of stake for Ethereum off the ground, and we've learned a lot since, have a lot more sophisticated understanding. So I would consider the beam chain basically the opportunity to really get to like the second generation of state of the entire like proof of stake mechanism on Ethereum. So there will be a lot of individual features to look at there. And then on the execution layer side, that's actually quite interesting. That I think has shifted more in the recent past, and that of course can mean that it might also shift more again going forward. But there seems to be a lot of renewed appetite now to look at the execution throughput on the L1. We have purposefully basically left that more or less at constant levels ever since the merge, really. But there's now quite a bit of excitement around uh, making progress there again. And actually, we'll have an announcement there towards the end of the call. But I would like to have that maybe be the main theme for the second protocol research call in a month. So I'll talk a little bit about that towards the end of this call. And then in the medium term on the execution layer, we actually have very exciting features that have already been kind of part of the roadmap for a bit of a longer time. That's primarily zk EVM and somewhat related, but also separate. This idea of native rollups, meaning basically using the fact that now you have this kind of execution compression technology also on the L1 to basically give overall a better rollup experience. And yeah, so basically my feeling would be that for many future research calls, it might make sense to focus on one of these sub areas and then really explore this. And then the nice thing is, given that we have the monthly, that maybe every few months we can also rotate through, look back at the category, see what has changed, these kind of things. So once we have a bit of a track record here, we can hopefully build up a bit of context. But of course, not every topic is just neatly fit, does not neatly fit into a single box. So actually today's topic, I think is a really good example, the role of home nodes in the Ethereum network that kind of covers all of these quadrants. So really, I think this is more supposed to be a bit of a guide. And actually, if you look at this and you really disagree, that's also probably going to be a good kind of basis for future conversation. Yeah, that's all.
Yeah, thank you, Ansgar. And so, yeah, as you said, today the idea is to do a bit of like this very transversal review of what home nodes do on the network and what are their means for. So what are the goals that they achieve. And I think the conversation around home nodes, local building, is often centered around their contribution, notably for censorship resistance and liveness of the network. And this is, yeah, obviously very valid because these are two big contributions of home nodes. But it does have consequences for other goals that the network may want to pursue, which are things like scaling or things like single source finality. And so one of the leading questions that we have today is, can we have our cake and eat it too? Or is it too good to be true? And trying to highlight perhaps some of the trade-offs and some of the different points in the design space that we can occupy, given, let's say, new research and new ideas, and also old ideas that are sometimes revisited in a new light. And so this call will be sort of in two parts. The first part will be really about local building and the question of, can we increase network throughput, so the gas per unit of time or the blocks per unit of time, beyond what can be provided by home nodes building their own blocks. That's the first part. And in the second part, we'll revisit the path to single-thread finality with a discussion on two approaches, capped validator set and orbit. The two parts also map roughly to summary post that I released on if research before this call, and that you can find on if magicians. And yeah, we have a couple of people coming in to present some ideas around this, and we'll also have a bit of open discussion in between for checking where we are at on these topics. So let's dive in. Please try to enjoy each presentation equally. All right, first part, decoupling throughput from local building. And I'll give it off to Tony on his latest post, expanding mempool's perspective, giving us a sense of what's happening today in the mempool. I'll let you share your slides, Tony.
Okay, yeah, I think I cannot share. While you're still sharing. Okay.
Yeah, try again.
Yes.
Yes.
Perfect. Can you see it?
Yeah, good.
Perfect. Yeah, hi everyone. My name is Tony. I'm with the Applied Research Group at the Ethereum Foundation, and I want to quickly present some stats on the role of local block builders, private order flow, and public mempool, all findings from my most recent ETH research post. So the question I started at was basically the same that Barnaby just introduced. Do we rely on local block builders for liveness and censorship resistance? And I think this is a very important question that we as a community at some point need to answer. And in order to guide us towards an answer, I wanted to quickly present some stats around the situation of local block building today. So let's start with private order flow. So private order flow is definitely something that has a huge impact on local block building. And as we can see on this chart here, we started last year at like 10% of private order flow transactions, and now we are at 35% of transactions that are not seen in the public mempool, those defined as private order flow. And we can see that although it quite significantly increased in summer last year, it then stagnated, and we are still at 35% of private order flow transactions. We can see the same in the green line in this chart. It's basically the green line shows you the number of private order flows, so the percentage of private order flow transactions over time. But the more interesting line in this chart is actually the red line, because the red line also shows you the gas used. So what we can see here is that although we have around 35% of transactions that are private, they consume around 50% of the whole gas. And the same applies to the blue line, which is the gas price. So we know private order flow transactions are not only using more gas, but they are also paying more, which of course makes the situation for local block builders even worse in terms of profitability. When we ask the question who gets all that private order flow, then the answer is basically the two largest builder. So it's Beaverbuild and Titan Builder who get most of the private order flow. And of course, private order flow comes with very strong economies of scale, because the more private order flow you get, the more slot auctions you might win, the better the guarantees you can give to other companies providing you private order flow. So this is, in my opinion, a kind of very strong centralizing force on the builder front. So to summarize, 35% of transactions are private order flow transactions. So local builders never see them. And thanks to Data Always, we also know that around 80% of the DEX transactions are private order flow. So this tells us that we are already very close towards this theoretical cap of private order flow transactions, because some transactions, it will never make sense to submit them as private order flow, for example, ETH transfers or something. Then 50% of the gas used comes from private order flow, and two builders are dominating the space, Beaverbuild and Titan. And this already has huge impact on local block building, because today local block builders their blocks are at around 7 million gas, so much below the 1559 target of 50 million, by now 18 million. And MathBoost builders, expectedly, their blocks are right at the 1559 target. So this kind of tells us local block builders might not be able to get their blocks full. And interestingly, when we look at different sequences, for example, what happens if a local builder builds on top of a local builder's block, then we see local builders are then able to fill the block to up to 14.5 million gas. So this is fine. But when a local builder builds on top of a MathBoost builder's blocks, then we get very small blocks of 7.1 million gas, and vice versa. We see MathBoost builders building on top of local blocks build very big blocks of 23.6 million gas on average. And of course, if you see that, you might directly think of timing games, because timing games might be a very reasonable explanation for this picture. And I tried to look into that, and what we see here is the seconds in the slot when the previous block was seen. So for example, a block seen in second 4 in the previous slot would be on the very right hand side. And then we see the lines show you the average gas used of blocks from the current slot. So for example, the green line, we can see it moves from 7 million gas on the very left-hand side to around 5 million gas on the right-hand side, which tells us if the MathBoost builder published its block very late in the slot, for example, the block was seen at second 4 in the slot, then the next block tends to be smaller. Instead of 7 million, we might see a 5 million gas block. And this relationship between the timing of the block and how full the next block is kind of more or less obvious for all those lines. So this brings me back to the initial question. So local block builders, as we just saw, are already in a very difficult spot, especially when it comes to profitability. They have no chance to compete with professional block builders, and block building is getting more and more sophisticated. We already seen the hardware requirements, EAP, where we differentiate between local block builders and standard validators, which is, I think it's good that we do so. But this, of course, opens the question of why do we initially require to have local block builders? And the two most common answers that you hear is as a fallback for MathBoost and as a backbone for censorship resistance. But I would argue that we have some solutions, especially to the fallback for MathBoost. We have solutions like having trusted but neutral relays and simple ways supporting them, like the PBS Foundation, to make it simple to spin up neutral relays, and also ePBS and other separation designs could help here. And on the other hand, we have inclusion lists where we can basically say, make inclusion lists and not blocks, simplifying the work for home stakers, so they don't need to become local builders, but we might want to have them as inclusion list builders. And this is maybe a little bit off topic, but just around the topic of censorship resistance. This shows you the inclusion of Tornado Cash transaction over the last year, because one might expect that it were the local builders that included most of the Tornado Cash transactions. But essentially what we can see here, especially on the lower chart, that the inclusion rate was larger for MathBoost builders than for local builders, which is something I didn't expect. That I expected local builders to be at least on the same level where all those MathBoost builders are. But it also makes sense because some MathBoost builders use Tornado Cash transaction as a competitive edge to outbid other builders in the slot auction. So kind of batch include a lot of Tornado Cash transactions to win against the big censoring builder. Yeah, and this brings me to the end. I will just leave that slide up. If there are any questions, I'm happy to answer them.
Yeah, thank you, Tony. If there's any question for Tony, please feel free to raise your hand. Do you want to take a question from the chat? I see both Kev and Thomas.
Yeah, let me check the chat very quickly. Or could you read it out?
Yeah, let me take Kev's question. What about blob transaction? And if blobs were to become more profitable, how would this change the profitability for local block builders, assuming most or all blobs are sent to the public mempool?
I I don't think this wouldn't change that much because blob transactions essentially are also just normal type 1, type 2 transactions from the perspective of a local builder, because what you get is basically the same prior fee as you get for type 1, type 2 transactions. So I don't think blobs will make a huge difference here.
And maybe another question from Thomas. What's your take on neutral relays versus EPBS and the trade-offs there?
Yeah, I think that's a very important question that we at some point as a community need to answer, because we can, of course, rely on trusted relays and have simple ways to spin up new neutral relays. But in the end, it's also a question of having a bug. For example, if we have a bug in a relay and it's not part of the core protocol, then we cannot really talk about very strong liveness guarantees.
And on that point, Marius has a question. How do you feel about relays not verifying blocks before forwarding? We've seen so many bad blocks because of faulty relay software already. So that seems to come back to your point around what we can control as like core dev community, I guess.
Yeah, exactly. At some point, if we agree on enshrining relays and then also having core devs be responsible for making sure relays work and the fallback functions work and everything is treated as the core protocol, I think this would be one solution to that problem. Of course, another one would be shipping something like EPBS, which is essentially enshrined relays.
Cool. I know there's...
For access.
Yes, George?
Έχω meeting, baby.
I will mute you. Okay, yeah. I think there's quite a lot to say about EPBS and relays. There'll be like a little bit more discussion. I'll just like give a few thoughts on basically the same topic, and maybe we can come back to that point. Let me go back to sharing the slides. Yeah. Okay, yeah, just wanted to introduce some visual language to talk about some of these things that I'll also come back to a bit later during SSF, and also addressing like some questions around what we mean when we say what's a home node, what's a local builder, like what are these entities that we're talking about and what kind of defines them. And the way I like to think about this stuff is we have roles that the protocol wants you to assume, and you have on the other side node types, so people mediated by their hardware, fulfilling the tasks or the roles that the protocol is demanding. The two roles that we're pretty familiar with is the role of attesting, so coming to consensus, coming to finality over what's the canonical chain. And the second role is the role of building, which is essentially sequencing transactions in blocks and making that available to the rest of the network. There's a third role that we're talking about more and more, which is a little bit related to the role of building, but that you can almost separate from building, which is the role of including. So the idea that parties decided by the protocol have the ability to enforce or to bind the construction of blocks to include certain inputs, transactions, or otherwise. So this is not a role that exists formally yet, or that has been really separated, but with a gadget like Fossil, which is an inclusion list proposal, is a role that we would see appear much more clearly on the protocol. So what this protocol will give you, testing gives you security, so you have like a hardness of the chain. Building can give you scale, because if you build big blocks, then you make these big blocks available, assuming of course that you can verify them. But including gives you like this idea of censorship resistance. So if transactions are for some reason being kept out of the transcript or being prevented from getting into blocks, you have like extra pipes with these includers that allow you to get on chain. And then you have these operator types, so people who are fulfilling these services. It's a very crude distinction, and it's not a binary one by any means, but I often talk about home nodes on one side and commercial nodes on the other side, or professional nodes. But really the distinction is not even one of resources, because some home operators or solo stakers spend a lot of resources, like lovingly upgrading their nodes and making sure that they're performing a very good service. So it's not one of like sophistication or anything, but it's more that home nodes are a priori untrusted, like they're just pseudonymous addresses on the network, and commercial nodes come with, let's say, some kind of credibility that is signaled either by some legal status as like a company, or just like reputation, or a DAO, or some signal that tells you that you have a trusted quantity on the other side, dealing with these nodes. And then you can also think of a further dimension to distinguish between like who's doing what, which is the actual resources of a node. So some nodes are minimal, and I think that's more what sometimes people have in mind when they talk about home nodes, is the idea that it's like these small NUCs or Raspberry Pis that are trying to come to consensus, like make these services of attestation and building. And then you have nodes that are much higher resource. So not just in hardware, let's say, not just like in compute or bandwidth, but also access to order flow, as Tony was mentioning before. That can be a resource that just makes your node like a lot more, a lot more able to perform certain services, such as building. And so local building is the idea that you have a home node, and in fact a minimal one in the case that would be like the smallest possible node that's on the network as a staking node, that performs this role of building. And the consideration is whether we can remove the expectation that these types of nodes, so minimal home nodes, perform the building task, and instead assign it to these higher resource nodes, and do that safely. And the questions that we should ask ourselves is, how do we make it safe? I think one answer is definitely Fossil. So the idea that home nodes are still able to perform their censorship resistance role via inclusion lists that constrain the builder when they make these blocks, and that can give you scale. But then the second question we have to answer is the one of liveness. So what happens when you call this external market or set of participants and just nobody answers, and then your blocks are not produced anymore? And it can happen just because there's a bug in the supply chain that makes the block suddenly not appear, or it can be much more adversarial scenarios where the market on the other side gets extremely concentrated and starts making demand to keep the liveness going. So very briefly on that, I think these are some of the guarantees that we may want from this external builder market. The first one is, if you make a contract with a builder as a proposer or as like a staking node, and if the contract is just made canonical, the payment should be received. So that's something that, for instance, you can get through EPBS or through guaranteed payment proposals. If you have repeated failures of the external market, you might want to have circuit breakers in some places, like either with out of protocol software, or even if we had like in protocol solution. when you make these calls to the market, like to figure out like who can build blocks for you, you might want to have like different protocols that allow you to make these calls. And so, for instance, you have today MEV boost and commit boost, and maybe that diversity is something that we should also be more intentional about fostering. Another thing is you probably want to reward builders that have higher quality of service, like that makes them build more blocks over time. So, for instance, making sure that payments go through is one way of rewarding higher quality builders, because you're penalizing builders that don't have such a high quality of service. And then you also want to ensure that you never put yourself or the network at the mercy of a single entity. In the post, I detail scenarios where we're moving to a zk-VM world, and then we need provers to ensure that the blocks are valid. We have to be very mindful about never putting ourselves in a position where only a single prover on the network can unblock the chain or make it progress. And I think there's ways to set like different sliders in different positions that should at least give us good guarantees or make us feel comfortable with certain trade-offs. But the larger question is, what's like the set of things that we need to really tell ourselves that this is okay to rely on this external building market, and less so on the local building as a feature, and that would allow us to scale beyond the limits of local building, essentially. So that was a pretty quick run through, but I would say through thinking about these topics, I feel like the two main questions that have appeared to me were first, are we ready to decouple throughput from what local builders can achieve? I think that's a question that comes back like fairly often in the discussions we're having, especially on the blobs. And then the second question is, how should we think about like ensuring the liveness of the blocks? And we have proposals for doing more in protocol. I think EPBS is definitely the leader here, but we also have ways to improve out of protocol options. And I think it'd be important to understand, what's the sufficient set that gives us what we want. And I'm sure there's a lot of discussion here. So I see already Ben has his hand raised. Please go for it.
Blobs aside, if we consider execution, realistically, since a large portion of transactions go through private order flow rather than the public mempool, which the local builders don't have access to, even if we dramatically increase the gas limit, I don't think it would necessarily impact local builders because they wouldn't have access to those transactions. They're going to build smaller blocks anyway. But I don't think it's necessarily a problem.
Yeah, and would you say that there's always I guess here I would call it worst case, where suddenly the local builder could realize like a much higher demand, perhaps because suddenly there's a lot of public flow. It's not a worst case because it's actually good for the local builder. But would we feel sad about the fact that in that case the local builder could just not build a block up to the gas limit? Like, is that something that we would be upset about? I guess is one question.
I mean, they'll do what they can do because I think it goes through sort of multiple iterations of improvement. But I don't think it'll necessarily be a problem. I don't think it's too much to worry about. I could be wrong.
And I saw that the chat was pretty active, but I didn't get to read it. Ansgar, do you see something in there that might be worth discussing?
Well, I think Marius had a question when you basically talked about the includer role and the builder role, and Marius basically was wondering, does that mean that the builder is then not supposed to include at all anymore? Is that not necessarily implied in that name? Like, how do you basically segment these roles?
Yeah, that's a good question. And there's actually different flavors of architecture, I would say. Uh, we could imagine a world where the builder has no agency over inclusion, so they have to only make their block out of the fossil outputs. And if you've heard of like these multi-concurrent proposals, these were essentially like doing that. Like you have a set of people, they each output like a partial block, and there's some kind of merging rule that takes all of these partial blocks and makes that into like a single thing. The fossil design that we landed on is not that. It's more conditional. It's actually weaker guarantees. So when the includer puts you in their list, the builder has to include your transaction unless the gas of their block is full. So we call that conditional inclusion. And the reason why we landed on this design is that it's very MEV agnostic. You can't really give good guarantees as an includer. And so that means the includer are a bit less likely to become very sophisticated about what they include. Like we really want the including thing to just be, you see a transaction in your mempool, you should dump it into your inclusion lists. No questions asked. I saw Asu was raising his hand. I don't know if you want to chime in.
I was just gonna write it in the chat instead, but I was about to say if you outsource all transaction inclusion to the includer, then I think that's quite dangerous because then the MEV auction moves there as well, to a place where it's not optimized for hosting an MEV auction, you know, and so you end up going back to a lot of these negative externalities on the network that we were trying to get rid of by having the builders in the first place. And so, yeah, you need, you know, you can amend the block through the transactions from the includer, but you want to keep the builder at a fairly high level of agency, in my mind.
Any last thought on these questions? And yeah, I saw Ansgar commenting in the chat saying that we're not settling these questions today. We're really just trying to get some discussion.
Yeah, I guess I can say a couple of words in general. I think this research direction is really good. I think that local, or like if you think from the perspective of Ethereum, it's really about how do you balance throughput and scalability with protecting the censorship resistance and decentralization elements of Ethereum that make it unique and that make that block space differentiated, right? And we have been providing this through local building, but it's, you know, it's a clear way to kind of get rid of this constraint on the network. And if you look at what other chains are doing now to scale, they do it by unbundling effectively the role of full nodes and into separate roles that, you know, can be done by nodes of different sizes, and that hold each other accountable. And I think the beauty is if you move to this framework, then you solve censorship resistance through the includers while still being able to scale the network much more on the behalf of the bigger nodes that do like hold the state and do the block building and this kind of stuff. And so for me, it's clear that this, you know, is a big part of the puzzle for how we can unlock more scalability for Ethereum without hurting any of the guarantees that we have today.
Yeah, thank you. All right, then I suggest, I think there's still some discussion going on, but I suggest to move to the next part. We really packed the call quite a bit today, but yeah, I think it's nice to be able to paint this large picture. So yeah, we also wanted to tackle these paths to SSF and bundling that a little bit with shorter slot times. It's possible to get shorter slot times without going like all the way to SSF, but I think it's pretty clear that to get to significantly shorter slot times, there's a pretty massive restructuration of the current consensus mechanism that's needed. So I think it makes sense to talk about them in the same breath, even though they're very different proposals in a sense. I'll just give a quick intro, and then we'll have a few more presentations, and again some open discussion at the end of that. Close that. So the relation between single source finality and home nodes is that we have essentially different designs that would allow us, in theory, to achieve SSF, but these designs have different trade-offs, and they mean different things for the validator set and its composition. It seems pretty clear that for any design of SSF, we need a relatively small active validator set. And there's essentially two ways to get there. So the first way is to use a rotation. So we have a large validator set, but we're rotating in and out people for participation. It looks a little bit like what we have today, but with the difference that we're not waiting for every committee to finalize. We finalize committee by committee, so it's more cumulative. That's one approach. And then the second approach is to just cap the active set and say we have this many validators and there can be a bit of churn, but the count remains fixed. And so, yeah, it's pretty clear that if you have a rotation, you allow yourself to have a larger validator set, if not a larger active validator set at any point in time. And so when you have a larger validator set, that means you pragmatically allow a lot more direct access for home nodes that maybe come in with like not that much stake. So that means in this case, the minimum effective balance you need to enter the validator set can be much lower. But this is quite hard, and Francesco will tell us more about it a bit later. And so to organize like the discussion here, I think what's important to have to make or to understand like what's the right trade-off to make is two things. Like first, understand what's the value of SSF and the shorter slot times and its value with like different configurations. And the second thing is understand the costs of these different designs and their cost both in terms of R&D, but also I would say in priority. So the longer we wait to ship useful features, the more we pay the cost of people having to wait for them and use less effective things in the meantime. And so in the first part, I invited 3 people to discuss the value of SSF. Each one will give a few minutes pitch on how they see this question. And after that, I hope that the 3 of them can start a discussion for some time. So I leave the floor to Donkrat first.
Hey, yeah, sorry, I don't have a presentation. It's more of a short sort of summary of my thoughts on this, like why I think this is an important topic. I think fundamentally, the way I see it, confirming and finalizing things is the most important value that blockchains provide. Like that's basically what they do ultimately. Like we now know that we can separate, for example, execution from data availability and so on. So fundamentally, in the end, you could say like whatever your base layer does is how much data can it confirm in what time. And how this in practice, why this in practice matters is if you don't do it at an acceptable rate at the base layer, then someone else will do it for you. Like then the confirmation will move to a system like Espresso or something else. And I think we should be very careful with that because it might just mean that if, for example, we care about value capture, then it's likely that this is one of the most valuable things you can do. So if we lose it, if we simply say, oh, it's okay if we're not the first confirmation that someone gets, we are like just okay if like someone finalizes something after 15 minutes and then I think like a lot of value will move away from the Ethereum base layer. And I think like that's not a great end result. I think like we should keep as much as possible in there and as quickly as possible, like give users certainty. Thinking about it more in terms of interop, how quickly the base layer confirms and finalizes is also like the fundamental limit on how quickly you can do like perfect interop in a way, right? So we know like we get later presentations on how you can do it with intents, which is cool. Like, I mean, that's a great thing and they're very helpful. But again, they have their limitations, like they require liquidity on both chains. So that means both chains need to like make this investment to get liquidity. And they don't work for NFTs. And like, there's all kinds of things that's limiting to them. And like, I think, again, they are like a nice additional feature, but the more confirmation value the base layer can already provide, the more value it fundamentally provides. So I think that's why like I do see having quick slot times and fast finality should be a priority for Ethereum.
Yeah, thank you. Very nice speech. Let me move on to Matt Rice from UMA. Are you here?
Yep, I'm here.
Okay, cool. I'll control your slides. I think it's just a bit easier, but is that okay? Right.
Cool. So yeah, I'm Matt. I work on Lacrosse. So I'm sort of the intent guy. But yeah, so I want to talk a little bit about how I see single slot finality, slot times, and interop sort of working together. Yeah, we can move to the next slide. So for intents, as was said previously, like I actually don't think that single slot finality is incredibly impactful. It has some impacts, but it's not the most. I don't think that users are going to notice a big change if we move to single slot finality for at the intent layer. But I'll sort of walk through why that is. So like solvers, if we did SSF, right, solvers would take less or no reorg risk in filling a user who's bridging out of mainnet. So higher speed, lower costs for users, which is good. I think these would be, fairly minor impacts, but they would be there. And then I think the second point is practically not as important today. We don't see it a lot. And it's that like L1 reorgs can induce L2 reorgs. So single slot finality would like slightly reduce L2 reorg risk, which means solvers can do sort of L2 to L2 fills with lower risk, once again, higher speed, lower costs. Faster block times, I think it just makes the experience of interacting with mainnet better, and that sort of extends to intents, right? It just makes the intent experience much better. You can do more complicated cross-chain actions and have it feel almost synchronous, whereas like if you're waiting 12 seconds per block, it like doesn't feel the same. So I think that I'd summarize this as like the direct impacts to intent interop are mostly felt by people interacting with L1. They're really not going to impact people who are interacting with L2 all that much. But I do think that there's sort of indirect impacts, and that's what I get into on the next slide. So like for messaging and large transfers, I think this is where maybe it gets a little more interesting. I still don't know if single slot finality is the answer, but I think a lot of what we see as the big blocker on for interop is the rollup withdrawal delays or rollup withdrawal windows. So like the most direct path to trustless cross rollup messaging is to use nested storage proofs that go through mainnet, basically. And the withdrawal delays are a major bottleneck, but for the most part, this is like not really dependent on finality being faster on mainnet. With this definitely impacts settlement. It also impacts like how solvers rebalance between chains, because obviously the canonical tokens often get minted by the canonical bridges. So you have to sort of go through this withdrawal window to do large transfers. And yeah, there's large transfers where intents don't work, where a user wants to just send $1 million between two chains. Intents are not going to be very good for that. And so you would need to sort of use sort of canonical message bridges to facilitate that. And so I actually think these withdrawal delays are probably the biggest single blocker for interop today, and the biggest problem we're facing in the intent world, but also outside of intents for helping users to interop between rollups. So I think it's actually causing, because we sort of have this bottleneck on these withdrawal delays, it's causing the ecosystem to move more towards centralized solutions, especially for token minting. So you'll see a lot of tokens actually start to use centralized operators instead of the native bridge. And if we go down that path, a rollup really doesn't inherit in Ethereum security because its assets are, at the end of the day, minted by a centralized operator. So yeah, I would just say ultimately, I think there are impacts around the edges that single slot finality and faster block times can have for interop, but I actually don't think that they're the biggest priorities for the interop world right now. Yeah.
Yeah, thank you so much. It was great. And yeah, let me turn it over to our last pitch from Justin.
Hey, so let me share a couple of thoughts on SSF and slot durations. In my mind, these are very different topics, so I'll consider them separately. So for finality, I guess what we want to do is, broadly speaking, minimize reorgs. And my mental model for reorgs is that we have three different types of reorgs. We have shallow reorgs, which only involve a few slots, and that might happen because of high latency or timing games or things like that. There's, on the other end of the spectrum, there's deep reorgs, like long range 51% attacks, which are very scary. And then there's the stuff in between just a few slots and multiple epochs. Now, what we have today, which is a 2-epoch finality gadget, you could call it 2EF, 2-epoch finality, is good enough for the really scary long range 51% attacks. And one of the things that I want to highlight is that single slot finality is a bit of a misnomer, and contrary to popular belief, it doesn't really help us solve the really shallow reorgs. So that is something that's kind of fundamental, and part of the reason why we renamed it to 3SF, three slot finality. So really the question is, what is the value of minimizing the medium reorgs? And there's a few notes that I would make here. The first one is that medium reorgs are exceedingly rare. My kind of hot guess, I guess, is that mainnet has never seen a reorg which 3SF would have prevented. All of the reorgs that we see, they're due to high latency timing games or momentary asynchrony or things like that. And if we did have 3SF, then we would still have these reorgs. Now, one reason to try and have mitigations against these medium reorgs is when you want to deposit funds to an exchange. Just from a UX perspective, the exchanges take a lot of time to process the controls, so the deposits. And here I would argue that we have something that kind of works today, which is this notion of a safe head rule. So as an exchange operator, within a few slots, you should be able to process the deposits with relatively low latency. And so this is more of an educational problem than a technical one. And then I guess another reason to try and mitigate these medium reorgs is to have resistant proof, real proof, pre-confirmations. So as was said previously, it's possible that the L1 can basically cause the L2s to reorg, and that's bad. But here you can have a similar mitigation where you make use of the safe head. And so overall, my position on 3SF is that it's not something super urgent that we have to do in the next couple of years. And then you might ask, okay, what is the value of 3SF? Well, in my opinion, there is still significant value, and we still should be doing it, but it's just not high priority. So the value would be 1, protocol simplicity, because we don't need these complicated committees. We can drastically simplify the fork choice and things like that. It's also very good for memetics, right? It's just a good look if your chain has fast finality. And it's also less cognitive friction for exchanges and pre-confers to have to work with the finality gadget as opposed to this safe head rule, which is kind of more subtle and hasn't really been adopted in practice. But those are my thoughts on the finality. On the slot durations, my take here is that any decentralized sequencer that follows a certain paradigm where you have this single leader election paradigm will basically end up in the situation where it has pre-confirmations. And the reason is that even if you have like extremely low slot durations, let's say just 1 second slot durations, that's still too slow for applications, right? Like applications want 10 millisecond UX or 100 millisecond UX. They don't want 1 second latency. And so in a world where you do lean on these pre-confirmations, you actually have the freedom to have more generous slot durations. And there's all sorts of advantages to having larger slot durations. It's more friendly to decentralization. You can have more active validators, which means that you can lower the minimum amount of ETH in order to become a validator. And you don't really suffer negative externalities from a UX standpoint, because again, the pre-confirmations give you that best-in-class UX, which is going to be there anyway. You can kind of think of pre-confirmations as being a sunk cost if you have adopted this paradigm of decentralized sequencing with a single leader at any given slot.
Cool. Yeah, thank you so much, Justin. Yeah, so I was wondering if among the three of you, like you've given like nicely different perspective on the value of SSF, or let's say shorter slot times. Like, is there something that one of the other panelists said that strikes you as, oh, this is very different from my own thinking, or a place where, yeah, there's an irreconcilable difference, perhaps?
I mean, from my perspective, I agreed with a lot of what Dankrad and Matt said, but I guess maybe in their mental model, they're not considering the pre-confirmations as even part of the design space. And I think if you are willing to accept this larger design space, then you can have really nice designs and nice trade-offs. Now, pre-confirmations are extremely like recent ideas, and only now are you starting to see systems like Base and Unichain and all sorts of other systems start signaling that they want to support pre-confirmations. And so really the proof is in the pudding for 2025 to show that yes, in practice, these pre-confirmations can be robust. And I think hopefully, in 2026 and beyond, we can start taking pre-confirmations for granted and kind of enter this pre-conf centric roadmap, if you will.
I mean, I feel like where I would kind of disagree is on the I'm again worried about the value capture side. So I think pre-confirmations on the base layer look a lot like just faster slots. So maybe if we want that, then we should move to very fast slots and a little bit slower finality. If we don't have them on the base layer, but have some other construction, then yeah, I'm worried we're giving too much away. Like we're giving potentially the most valuable piece of the stack away. And that would make me quite worried. like to make that the official position. Hey, we want someone else to do this thing for us.
But my definition of a slot is basically the amount of time it takes for one round of attestations. And like my assumption is that we're dealing with a fairly large number of attesters and, in a decentralized setting with home internet connections. And so, the realistic number that I have in mind for a slot duration is roughly 1 second. On the other hand, with pre-confirmations, the notion of time is a tick. So that's the minimum amount of time that it takes for one single entity, the proposer or the sequencer, to make a decision on giving out these promises to users. And the tick duration can be as low as 10 milliseconds, which is 2 orders of magnitude faster than the fastest we can achieve with slots in a decentralized setting.
Right. I guess like I would still contend that if this is what we want, then we should bake it into the base layer somehow. We should add a way of confirming these as intermediate blocks by the same proposer, with at least some, obviously not perfect, checks by attesters. Like we don't necessarily need round trip latency on those. We can do that on higher resolution than round trip latency, if they mean anything at all.
One of the things that we've kind of observed is that in order to have robust kind of incentive compatible pre-confirmations, the amount of economic security needs to be fairly small because we're dealing with very small durations of one slot. And like ballpark number is about 1 ETH of economic security. And so that's the kind of collateral that doesn't require attesters. It's something that a single sophisticated proposer in the context of APS can single-handedly provide, and provide robust and incentive compatible reconfirmations.
Thanks. Yeah, maybe I think there's a lot to say on pre-confirmations. I wanted to ask Matt, at the end of your talk, you mentioned that SSF shouldn't be the priority for interop. And I've seen the question also in the chat. In your sense, like then what should be the priority things to ship at VL1 or otherwise that would help have better interop like throughout Ethereum?
Yeah, I think I put in the chat, but I think it's like I know there's work at the EF already around standardization. I think the whole intent world needs more standardization. So that's a big one. I think there needs to be a lot better wallet support for cross-chain actions, things like just like better support at the wallet layer for this. And then so users can sort of combine like an action they want to do on a dApp with sort of a bridge to get the funds there. And then like I think like faster / better trustless messaging. I think there's a lot of trust dead messaging systems that are sort of taking the place of what trustless messaging could do if it were better. And I'm concerned to see like a lot of the space just sort of leaning into like what I'd call like multi-sig messaging, because we can't do roll-up to roll-up messaging quickly and trustlessly. There's just not a good way to do it with ZK proofs. There's not a good way to do it with through mainnet withdrawals. So that's painful. And then, like I said during my little talk there, I think like decreasing the amount of time it takes to actually pull funds out of the rollups back to mainnet would be a huge deal. It would make interop way better and way higher throughput. So those are the big priorities from my perspective.
Yeah, thank you. And do reconfirmations maybe address some of it? Like, can we think of them as enhancing this faster or more trustless messaging?
I mean, pre-confirmations, I'm not sure how they would get you there, because like we're talking about like, I mean, the big barriers right now, I think we're talking about like 7-day delays on withdrawals, right? And like, I don't know how pre-confirmations on mainnet would really do much there. I think once you have these withdrawal delays get really, really short, like finality on mainnet and how fast you can actually move stuff through mainnet actually starts to matter a lot more. And so I could imagine down the road that being having practical implications on interop, but maybe I just don't see it today. I don't know if Justin has a different perspective and thinks there is a way this has an impact today, but I just don't see it.
I mean, I have a totally different worldview as to, what is a successful, ecosystem of L2s that has strong network effects. And basically my worldview is synchronous composability versus async, which is, I guess, your worldview. Like the thing that makes me like most bullish on synchronous composability is just the empirical observation that any blockchain ecosystem that has tried to embrace asynchrony, whether it's Cosmos or Polkadot or Near or Ton or the Internet Computer, they've all basically haven't had this product market fit with the devs because the DevX is just so bad. And in order to achieve synchrony, you need like a few magical things. The first one is the real-time proving. We're getting that, in a matter of months. But then the really hard thing is having all of the L2s converge on this shared sequencer. In order to have a shared sequencer, you need a credibly neutral shared sequencer. And unfortunately, we have only one of them, which is Ethereum L1 itself. And the way that pre-confirmations come in is that it makes the only credibly neutral shared sequencer actually good from a UX perspective because it reduces latencies. And so for me, pre-confirmations are like absolutely key to achieve this good interop. But I agree with you that if what you're aiming for is just this weaker notion of asynchronous composability, then you don't need these kinds of L1 pre-confirmations.
Yeah, I mean, I think user, just to say really quick, I think our views are actually pretty compatible here. My view is that like if those magical things happen, I think synchronous composability is like definitely better than asynchronous composability. I think it's a question of whether we think those things are achievable and over what time period. And like one barrier today is like I think it's going to take a while to build out. I believe like even if we did have like if we were able to have real-time proving, you'd have to build that out for every single L2, L2 chain, right? And so you'd have to go and like actually write that. Somebody would have to go out and write all of those circuits or all those proofs, and that from what I've seen, that's going to take a considerable amount of work and a considerable amount of time. But yeah, I think that's a completely compatible view.
Yeah, thank you both. Yeah, I suggest it was a very interesting conversation. I suggest to move on to the next part, which is more on the cost of SSF, having discussed now the value, and I leave it to Francesco to give the presentation here.
Should you move the slides or do you want to stop sharing?
Up to you. I can stop sharing.
Okay. Yeah, so going back a bit to something that Barnaby was talking about before, this last segment, we have these two main mechanisms for leader selection that are being considered that he discussed in his post. One is the easier one, the capped validator set, where we just really have a fixed number of validators that we can allow, and somehow we ensure that. And there's like different mechanisms that you could do this, but it doesn't super matter for the purpose of this. And then there's Orbit or some kind of more committee-based thing. It doesn't have to be necessarily Orbit, but focusing on Orbit, the idea is that you would rotate validators proportionally to their balance. And so yeah, if you have more balance, you'll be in more often. And you actually only cap the active set. So you still get capping, but not for the whole validator set, just for the people that are actually at a given moment in time voting. And yeah, the main complexity just standalone when you're just thinking about the leader selection mechanism is not in the leader selection mechanism itself. like we have committees already. We kind of know generally how to deal with them in terms of just selecting them. It's mostly just in the incentives. For the cap validator set part, it's still not. It's a little simpler. It's not necessarily there's questions there, but they mostly revolve around basically large stakers splitting their stake to push out smaller validators. It's at least something that I think it's a bit better understood. Whereas for Orbit, there's all these questions around consolidation incentives, which I think were like there's been a lot of research by Anders, which I think is on the call. But yeah, I think this is something that's much more recent as even like part of the design space. And it is actually really necessary in order for this design to make sense, not only for it to be useful, but also to be secure. And then there's, so that's the leader selection part. Then there's the consensus protocol part, which, we've been saying SSF for the most part. I'll focus on 3SF, like that Justin already mentioned. So 3-slot finality, where basically the idea is we kind of pipeline everything over slots, so we don't try to do all of the rounds of voting that we need to finalize in a single slot, but we only confirm a block in the first slot. And this is something related to the discussion that was in the chat about the confirmation rule. It's not the same confirmation rule that was mentioned there, but it's still this idea of having a strong safety guarantee that isn't finality at this point. So it's not like slashable or anything like that. And then, justifying and finalizing over the course of 3 slots. And each slot kind of looks the same as today's slots. You still have proposals, and you still have a head vote and a FFG vote bundled together. But you do have kind of 2 more things that are going on that I won't say too much more about. Small aside about this is that this is basically what Justin was saying before. Given that we want dynamic availability, so we want this property that the chains still make progress, even when we cannot finalize, we have less than 2/3 that they're voting. SSF does not mean that we don't have reorgs. So saying single slot finality versus 3-slot finality doesn't have this kind of fundamental difference of, somehow magically single slot means that there's no reorgs. Like that just isn't the case. So actually the trade-off difference between 3SF and SSF, it's really just that in one case you are having a smaller block time, but you accept like a longer finality time and vice versa. And so on the leader selection side, we kind of discuss the complexity was mostly on the incentives. Then there is like some consensus complexity that's kind of shared by both of them. Like no matter which of the 2 leader selection mechanisms you choose, you kind of inherit the same consensus complexity from the underlying like 3SF or SSF mechanism. One of them is just these 2 phases that I mentioned before that you add to the slot. So this confirmation phase, which is what you kind of use to get to this orange confirmation state. And it's kind of necessary for reasons that I don't have time to get into. And then this freeze phase, which is basically this synchronization mechanism that's meant to replace proposer boost and like in some ways be better than proposer. I mean, in a lot of ways be better than proposer boost, but also just extra complexity. And it doesn't have to be exactly this mechanism, but we generally know that all dynamically available protocols around have something that looks like this, like some kind of synchronization mechanism. So likely there has to be something there that's put in the slot. And then there's the main thing is for, again, reasons that I don't really have time to explain, but like security related, let's say, you probably would want to bundle this like big consensus change with a quite big change in the way that FFG and LMD goals interact, which for people that are familiar with this, it's removing force choice filtering. But yeah, I would assume most people are not familiar, but just think of it as like a really big, in some sense, kind of change deep in the way the force choice works. And so it has like a lot of ramifications and kind of involves a lot of complexity. And finally, so this was things that are that's consensus complexity that's kind of shared by both the cap validator set and orbit mechanism, whereas there's a bit of complexity that's more just specific to orbit and in its relationship with the consensus protocol. And so specifically, this is because of this committee rotation, just the fact of having committees and the fact that these committees are, unlike today's committees, responsible for finality. So you really, like as Barnabé said, like we don't get finality once all of the committees speak, but after a single committee speaks. And this means that we can just rotate kind of carelessly like we do today, like every slot or over just a period of time, because that would essentially break finality. Like you cannot have different committees finalized in different things. And yeah, this generally is somewhat challenging, even just rotating on finality. So like once you finalize, you just change to the next committee. Doesn't quite work. It seems like it should, but basically it fails because we don't have a unique notion of the next finalized checkpoint. Like very quickly here, you can see there's that A is finalized. There's this link, but maybe this link is not. It's not known at first, or in some kind of part of the network, people don't know about this link. C also gets finalized. And depending on what you see first or what gets processed on which chain first, you might basically do the committee rotation in a different way because someone might see A as the next finalized and someone might first see C. And this is kind of just a property of how the current consensus protocol works, which can be changed, but with some cost. So yeah, this is like a big kind of source of complexity added to all of the general like re-architecting of the consensus protocol. So far, the best solution we've seen is basically trying to get actually this single notion, like unique notion of next finalize or finality height. And it would basically involve a testing with a finality height and also adding a new slashing condition that's kind of related to this. And this, it's somewhat messy, and I mean, hopefully there's other solutions, but so far it's definitely added some complexity to the whole work of like trying to spec out something like 3SF. And so we've been like also because of this just focusing more on the simpler version, which I think anyway, basically all of the things that you need for the orbit version of all of this, like you also need for the all the things that you need for the easier, like the cap validator set version, you also need for the orbit version. And yeah, with that, I would conclude and pass it back to Barnabé.
Yeah, thank you so much, Francesco. Just wanted to bring it back to this question that we started from on the home nodes and maybe what the picture looks like for them in these two different proposals, Orbit versus cap validator set. So it's very clear since Orbit allows this rotation that the validator set can be much larger. And what this essentially buys you is just direct participation of nodes, including solo staker, which I represent here as people who have their own node at home. So like a priori untrusted independent nodes and who also bring their own stake. So that's the situation that's, your life gets a bit easier because you can enter directly into a validator set. The models that seem more favored in the cap validator set world, especially if the cap is fairly low, though as Justin mentioned in the chat, it's also possible over time to increase the cap. But the models that seem like more appealing there are either a combination of distributed validators. So you have several home nodes that are essentially hiding behind a single logical validator that makes attestation. So you're not directly like participating in the validator set, but you are indirectly by participating in that network, which is more, let's say, off-chain. And the second mode of participation could also be something that looks more like delegated staking on home nodes. So we have protocols today like receive the delegated stake that they need to reach the minimum effective balance, which today is 32, but would be dynamic in the cap validator set world. And yeah, the question is, are these options like satisfactory enough? Like, do we are we very attached to the solo staker model as opposed to these more like home operators in different configurations? And yeah, I think that's basically the crux of this decision. Yeah, I wanted to just open it up a little bit. We have 7 minutes left, so we can discuss for a few minutes on this. If anybody has thoughts, please raise your hand. Or Ansgar, if you saw something interesting in the chat that you want to highlight.
Yeah, I mean, for example, there was the conversation around what the capped model would mean effectively for the minimum balance for participation, right? And so how that depends on to what extent there will be consolidation or basically delegation to a few very large entities or more kind of equal distribution and potential griefing attacks and all these kind of things. So maybe, yeah, I don't know if you have some more thoughts on this. You already touched on it, of course.
Francesco, is this an answer to these questions?
No, it was something else.
Oh, I see. Yeah, I guess one thing to say is we do have like some control parameters. So setting the slot time to some value means that you give yourself like more room to have maybe more validators in the cap. I think the griefing risk, so big validators splitting their stake across many smaller ones to like push out to make less seats available for smaller validators to come in, like they can happen. They feel like part of the defense to me feels like it relies on the social layer to tell people, yeah, you should consolidate and making that easy. So in protocol, like now we have MaxiB. In the future, like I discuss even enshrining more of these delegated proof of stake type infrastructure to make that even more legible and easy to opt in. And then the second layer is more about defensive in a sense. Like you could imagine something like a fee or per seat, but I think that starts like to make the incentives pretty tricky. But we also have the opportunity to reduce the risk of people having more stake on a single seat, like we've already done it with MaxiB by removing or reducing the initial slashing penalties and increasing like some of these thresholds. I think as long as we keep the guarantee that at least one third of the stake is slashed when we have a finality safety fault, that seems like a good enough condition, and we can play with the other parameters to make the proposition more appealing. Maybe Francesco first.
Yeah, just wanted to say that to me it feels like, and I am partially why I'm kind of excited about this calls, that answer to this, like is the cost of Orbit worth it, is very much dependent on what's the timeline. Like if you were to say that the timeline is probably even like 2 to 3 years, I would say most probably not. I mean, maybe it's not even realistic, but if the timeline was 5 years, then yeah, I mean, maybe, or like at the very least, I think it would be a much less pressing question to even come to a decision on this. And yeah, it would be much more okay to kind of keep working on both things in parallel, or maybe keep working on the easier things, but like build it up and eventually be able to figure out what are the missing pieces to go beyond that. So I think it really depends on that as well.
Yeah, makes sense. And I wanted to prompt you as well on the confirmation rule. So let's say we're not so much in a hurry to move like to SSF, and it's been discussed a little bit in the chat. Like there's been this work on confirmation rules that exists, but that just hasn't really been deployed. I wonder if either you, Francesco, or I know Potus has also worked on it, can tell us a bit more about how much mileage can we get from such an alternative.
Yeah, I mean, I quickly just say kind of what the thing is about. It's basically just a way to use the votes that you see in a slot, which is already like a significant portion of the validator set voting. Like, I mean, 1/32, but it's still like a lot of ETH that's voting, and it's sampled with a committee, so there's like a lot of security there. It's not slashable security, but still to basically get like very quick guarantees on the safety of a block that's been just proposed. And it's kind of like parameterizable depending on basically the kind of adversary that you're worried about. So depending on how much voting weight you see, and I mean some other like more like technical things, you can basically get a number that tells you like supposedly under these assumptions, this is the highest adversary that you can tolerate. Then in practice, not entirely sure. It's not something that I've followed the development of much in the last, I don't know, probably year or more. So maybe POTUS can say more concretely about like what's going on there with the. I think you mentioned in the chat that Prism has an implementation of it. So yeah.
Yeah, POTUS left. Maybe I can give a high level detail. So we have an implementation. We have been testing it for a while, but because of like Petra and other items, we kind of dropped the priority. So now Petra is on the door out. So we'll probably prioritize it in the next coming weeks. But yeah, so we have an implementation. We have been testing. As far as I know, Prism is the only consistent layer client team that has it. So I would love to see more client teams jump on board. So I mentioned in the chat, Roberto, Mikhail, and myself are in like this working group that we're constantly talking about this implementation. So yeah, if any client team is interested in implementing it, please let me know.
Yeah, thank you, Terence. Cool. Yeah, I noticed that we have 1 minute left. I hate to stop good conversations, but I think it was also part of the fun of this call that we had like so many topics, and I hope that gives you like a sense of what happens in the head of a researcher for 90 minutes. We just bounce around between different things and try to explore all the angles. To keep the conversation going, these are a few suggestions. We have a new protocol research call channel in the ETH R&D Discord server. We'll try to make it live. I'll post an Ethereum Magician thread with the slides, material, some follow-up on these questions. And feel free also to comment directly on the ETH research posts. There's one by Tony, two by myself. There's a new tag for that. I'll leave it to Ansgar to give us a teaser of what the next call could be about.
Yeah, awesome. So next call, so we want to have these calls once a month. Ideally, the rhythm we want to aim for is always the first Wednesday of the month, this time slot. We'll probably lock this in soon. But so if you have feedback that this time slot is really terrible or something, of course, do let us know. But we are kind of currently aiming for that. And so the next call then would be May 7th. And the topic there, Barnaby, can you go to the next slide? So basically, if we go back to this rough picture here, I actually would want to basically specifically here exactly focus on this one bottom left quadrant here for the next call, the execution throughput. Of course, we already touched on some topics there, specifically around leveraging more, having heavier builder nodes than what is necessary for just validating, so for just executing. And so there's a few features actually in the pipeline right now. Some of them leveraging this, some of them in general just trying to get us more execution throughput. There's in a way like a lot of pent up low-hanging fruit feature overhang because we just have not focused on this for a while. Focused more on other topics on the L1. So this is just a non-conclusive list of topics that we might touch on and that basically I see at least as potential candidates for the fork after Fusaka. So Fusaka is already pretty locked in with the feature set. So that this is the first kind of open fork where there's still room for new features. Of course, we could not do all of them at once, but basically just to give you a bit of an impression. So delayed execution, meaning basically you give yourself more time to actually run the execution payload of a block instead of just a few milliseconds. It could basically take several seconds to execute. You just have to be done by the next slot. here to mention that EPVS, which POTUS has been championing for a while, is a bit of a competing feature there, somewhat different in what it gives you, but it's related. So it's not clear that we could do both. Maybe we would basically have to figure out a bit more the exact kind of comparison here. And then there's block level access lists, which are supposed to give you better access to state, because you basically pre-declare the block builder. It's one of those things where the block builder would still have to like go manually and slowly load all the state from disk when building, but then they would basically attach a list of all the state accesses to the block that they created, and that makes verification faster because you can basically prefetch all of that state from disk. Some parallelization. I think the general sentiment is that you can't get too much of a multiplier out of parallelization, but maybe say some sort of three-threaded parallel execution. So basically like a factor of 3 in terms of compute throughput. How could you make that work? Then there is P2P improvement specifically around bandwidth needs. So can we basically somehow reduce the kind of the multiplier used for propagation? Right now, I think that's on average like 8x kind of overhead in terms of how much the size of the block is versus how much you actually use in terms of bandwidth when propagating it. Can we get that lower without kind of latency issues? And then compute gas price harmonization. That's the one effort that's already the furthest along, and we have an active kind of resource pricing breakout call. And that David is leading, and that specific topic of compute gas pricing harmonization has been championed by people from Nethermind and some other people. And basically the idea is just make sure that all compute costs the same in terms of like how many milliseconds it takes, so that you can basically, you don't have like individual precompiles or something that are way too cheap compared to everything else, or other compute operations that are way too expensive. Call data gas dimension just basically gives you a much better handle on like using the available data space on the call data side efficiently. And then the last one I wanted to mention, it's a bit of an odd one out here, but Guillaume has been championing statelessness for a long time, with potentially Merkle trees, or there are also other ideas how to get there. That one would be something that's like a much bigger feature than the other ones. So that's probably not something we could combine with too many others. That might be an alternative vision of like basically focusing on this one instead of kind of like some sort of mix of the other ones. And there's quite a few open questions specifically around like what would that world look like. So that might be like a really interesting kind of like alternative vision to contrast these others two. So that's kind of a bit of a preview. If that sounds interesting, I would hope to see you on the next month's call. Oh, and the last thing, of course, and also if there's something maybe that's not on the list that should be on the list, or other things, like do basically feel free to reach out, propose these things, and we'll have another ETH Magicians thread with where you can propose extra topics. And if you want to maybe give a presentation on a related topic, do reach out. And next call I will lead, most likely, not Banabe. So yeah, reach out to me and yeah. Awesome, thank you.
Yeah, thank you so much, Hans. Yeah, and thank you all for participating for the first call. I hope it was a good experience. All right, see you soon.
Bye.